Good morning, friends. We are discussing Newton's laws of motion, and last topic that was discussed was rolling friction. We know there are three kinds of friction. One is a static friction. Second, it's a kinetic friction. Third, it's a rolling friction. Now, the most important topic from the chapter we are going to discuss, that is the circular motion and banking of the road. Let us see what are these topics. It's a circular motion. In previous chapter, we have seen that when the body goes along a circumference of the circle, then there is v square by r is the acceleration acting on the body. Here, if the body is moving along the circumference of the circle or performing circular motion, then the acceleration acting on the body is v square by r. A is equal to, which is called as centripetal acceleration, which is also equal to omega square r. V is a linear velocity, omega is angular velocity, because relation between v and omega, v is equal to r omega magnitude wise. Now suppose m is the mass of the body, then force is equal to m into AC, which is equal to mv square by r, and this is known as centripetal force. This force is known as centripetal force. It is always directed towards the center and along the radius of the circle. The centripetal force is always directed towards the center and along the radius of the circle. Now, this centripetal force, which is required object to take a turn along the circular path. Whenever the object is taking turn along curved road, then centripetal force is required. Now let us see. Suppose that this is the curved road. Here is an object and it's taking turn. The forces acting on this one is weight, which is equal to mg. Another one is normal reaction. Third one, that is called as, if it is at rest, then only vertical is there. But whenever it is taking turn, there is a centripetal force here. And this centripetal force is provided by force of friction. Therefore, centripetal force is always given by force of friction. Now we know force of friction, Fs is equal to mu s n. From this one, W and R, vertical direction, this is also called as N. In notation, sometimes R notation is N. Book, if you see, notation for reaction force is N. Vertically, there is no acceleration, therefore we can write it as N is equal to mg. Vertically, these two are equal and opposite. So then, centripetal force, we know mv square by r, which is equal to Fs, which is equal to mu Sn. But this is the maximum one. It will be always maximum one. So this velocity, for this one velocity becomes maximum. That is mv max square by r is equal to mu Sn. N is equal to mg, so we can write it as v max square by r is equal to mu s mg. This n is cancelled. Vmax, maximum velocity by which it can take turn along the curved road, is equal to mu s rg, or Vmax is equal to under root mu s rg. From this figure, you can note that maximum velocity to cut the curve across the road is independent of mass. Here there is no mass. It means that for car, for motorbike and for truck, even though the masses are different, maximum velocity by which the vehicle can take a turn is mu s rg, where mu s is called as coefficient of static friction, r is known as radius of curve, and g is known as acceleration due to the gravity, acceleration due to the Earth's gravity at that point. So here g will remain same. We can increase the maximum speed to cutting across the curved road by two ways. One is by increasing static friction, coefficient of static friction, and second one by increasing radius of the curve. In both the cases, there are limitations. As soon as you try to increase coefficient of static friction, for doing this one has to make a road more rough. And as soon as you make a more rough road, speed automatically gets controlled. So, we cannot increase safety speed beyond a particular limit. So, safety speed is always mentioned at the corner or at the curve, and we have to drive our vehicles with less speed. This is one way to get a safe driving along the curve. Another one, it is called as banking of the road. Second one, this one was the friction. Another one is called as banking of the road. Second case. What is the meaning of banking of the road? Let's see. In case of this banking of the road, we can see this one. If this is a horizontal road, this is inner curve. Outer curve is kept at slightly more height. Thereby, the surface of the road makes angle with the horizontal. See this one. The surface of the road makes certain angle with the horizontal. It is called as banking of the road, and the angle is called as banking angle. Once again, I say. Just we want vehicle to be pushed toward the center. If this side we lift it up, automatically it will be coming to this side. So outer edge of the curve is slightly at more height as compared to the inner curve. This process of keeping outer edge at higher level is called as banking of the road, and the angle made by the road surface with the horizontal is known as angle of banking. In this case now we are only considering banking of the road. Here it is banking of the road. Let us see, this is the vehicle, this is the weight, W is equal to mg. We all know normal reaction is always perpendicular to the surface. N is perpendicular to the surface. Thereby, N we can resolve. This N can be resolved into two components. It is N cos theta this becomes theta, and there is another one which is coming here, n sine theta. We can see if these are two radii, then these two are tangents. We know that angle between two radii are same as that of the angle between corresponding tangents. Now let us see what are the forces. These two, first one, that is n cos theta is equal to mg, equation number 1. Now this force is taking vehicle towards the center of the curve, and this provides necessary centripetal force. Therefore, n sine theta is providing necessary centripetal force, which is equal to mv square by r. This is equation number 2. Dividing this by this, so n sine theta divided by n cos theta, which is equal to mv square by r into 1 by mg. We get it v square by rg. This n is cancelled. We get it as tan theta is equal to v square by rg, or from this one v square maximum is equal to rg tan theta. V square max is equal to, it is square. First one we are taking it as a square, rg tan theta. So maximum velocity by which the vehicle can take a turn along the curved road is called as rg tan theta. This is the maximum speed by which the vehicle can cut across a curve. Now let us come back to here also. It is independent of mass of the vehicle. Now by using friction, Vmax is equal to Rg into mu s. Comparing these two, we get mu s is equal to tan theta, or theta is equal to tan inverse mu s. So here again we are getting maximum velocity Rg tan theta. Theta is angle of banking. Now we are going to combine both the things, banking of the road and the friction. In this one, let us see what happens when both the things are considered together. Circular motion. Here it's a safety speed of vehicle weight, friction and banking of road. Consider both the things we are considering here together. It is banking of the road also and safety also. Let's see the figure. This is horizontal, so it became, here is the vehicle, it's a weight mg. Here is a normal reaction, and force of friction we can show it here. This is the force of friction. Now here it goes. If you see this one, it is n cos theta, because this one is theta, this is also theta. Now this force of friction we can resolve. Along this one, there is one force which is n sine theta. Now in this angle, if you are taking it, this one is that. This is coming here. Now towards this side, it becomes Fs sine theta. This one, when this side becomes a front side, this side becomes adjacent side, that is Fs cos theta. So So this angle is theta. This is Fs. This one was Fs parallel to surface. Try to understand. Fs is a parallel to surface. Mj is in downward direction. N is normal reaction. Here n cos theta we resolve to this side. It becomes n sin theta. Fs we resolve into two components. Fs cos theta and Fs sin theta. Now at this point, we will see the forces under consideration. Now vertical direction. N cos theta is in upward direction, which is equal to mg plus Fs sin theta. Equation number 1. Vertical one, this is one here, n cos theta, and two forces are in downward direction. So in equilibrium, or they are equal. In this direction, this is providing necessary centripetal force. This is providing necessary centripetal force. Therefore, n sin theta plus Fs cos theta is equal to mv square by r. Because centripetal force is this. Now this one you consider first. Again, we get it. This side it remains mg. It is n cos theta minus Fs sin theta, because this one will come to this side. This is nothing but equation number 3. Check. What is Fs? Fs is equal to mu into n. Mu s into n. Therefore, this equation becomes n sin theta plus mu s n cos theta, which is equal to n sin theta mv square by r. Check it. Here I substituted mu s n. Similarly, in this case again, n cos theta. N cos theta, this one is minus mu s n. It is a sin theta, which is equal to mg. Fs is equal to mu s n. Take ratio of this one. We are taking ratio of this one. So n sin theta plus mu s n cos theta divided by n cos theta minus mu s n sin theta, which is equal to mv square by r into 1 by mg, which is equal to v square by r. Now n is common from all. N we can take it common. It becomes sin theta plus mu s cos theta divided by n cos theta minus mu s sin theta, which is equal to v square by r. N is cancelled. You can further take this one. This is, here we can write it, n r sin theta plus mu s cos theta divided by cos theta minus mu s sin theta is equal to v square r. Let us see. We can further simplify it. Just I love this one. So, this equation now, to this term, we divide by cos theta. So, numerator sin theta plus mu s cos theta I divide by cos theta. Similarly to this one also, cos theta minus mu s sin theta I divide by cos theta, which is equal to r. Sin divided by cos, here it becomes sin theta cos theta plus mu s cos theta cos theta. It is the cos theta minus mu s sin theta cos theta, which is equal to b square by r. This becomes tan theta. This is 1. This is 1 minus. So we get it. Tan theta plus mu s divided by 1 minus mu s tan theta, which is equal to b square by r. So from this one, b square is equal to rg in the bracket mu s plus tan theta, denominator 1 minus mu s tan theta, or v max square. V max is equal to under root rg mu s plus tan theta divided by 1 minus mu s tan theta. This is the expression of safety speed, maximum velocity with which the vehicle can travel across the curve. It also is independent of mass of the vehicle. It does not depend upon the mass of the vehicle. Now from this one also we can derive two special cases. For example, let us see, from this one we can derive special cases. Here I come to this one. First special case, if tan theta is equal to 0. Case 1, tan theta is equal to 0. V max is equal to under root rg. This becomes 0. This term will also become 0. Therefore, it remains only mu s, which already we have derived. Second case, if mu s is equal to 0, V max is equal to mu s is equal to 0. This is 0. This is 0. Then it will only remain tan theta rg. This was derived in case of banking of the road. There are few problems. This is all about theory of this banking of the road. We consider first centripetal force. Second one, we consider that the safety speed by using only frictional force. Third, safety speed by using banking of the road, then combination of both, and from that combination we again have seen the special cases where only friction is considered. Second, where only banking of the road is considered. That's all about these topics. Problem we will see it in next slide. Thank you.